Hi everyone. So this tutorial is going to be on your soils and the environment module. So this here I have on screen is our module specifications for the soils module. So these specs are available to you for all the modules, and these will go out in the email. So I suppose what's included in the specs to have a look down through. So we have the learning outcomes. So as part of the soils module, there are 12 different learning outcomes. So this is a level 5 module, 12 learning outcomes in it. And all of those learning outcomes have to be assessed at the end of the day. So I'm not going to go through all the sections because I will be doing that in the tutorials, but I suppose they are there for you. They're available. You can see the what's covered in each chapter down along. Just to come to the assessment, so the theory part of the environment module is worth 60%. So like all the other modules, you have to pass the theory component as well as the practical component. So in order to pass the theory component of this module, you have to gain 30% out of the 60% overall. So there's 2 written exams based on sections 1 to 4 and sections 7 to 8. The first written exam is 20 short questions at 1% each and 2 structure questions at 5% each. And the format is the same for the second exam. It's 20 short questions and a minimum of 2 structure questions at 5% each. The exams, they cover all the sections. So we will have a question from each learning outcome on the exam. I suppose the skills, the practical assessment, that's worth 10% then of this module. So there's a practical assessment and that's based on sections 5.1. So basically taking a soil sample and investigating the texture of soil. So there are the skills. Again, you have to get at least 5% out of 10% in the practical element of it to pass the module. The assignments then are worth, they make up the last 30%, and 2 very short assignments based on sections 5.2 and 6. That assignment is worth 20%, and assignment 2 then is based on section 9, and that's worth 10%. So look, I'm not going to go through the assignments. That will be done in a later tutorial. This tutorial, I suppose, is solely on chapters 1 to 4 of the soils module. So I suppose that's just to show you that the specs are there, they're available to you, so to make use of them and to see what's included in the specs. So for the next 35-40 minutes, I'll go through the chapters 1 to 4 on this module. So look, my email is there online at palacehenry.com if you do have any questions on this module. So as I said previously, each section is broken into a learning outcome. So the first learning outcome on these chapters is learning outcome 1. So describe soils in terms of classification, type, distribution in Ireland, formation and properties of productive and non-productive soils. So basically we're going back to the basics and looking at how soil is formed, the different types of soil, and I suppose productive and non-productive soil, so the properties in relation to that. These are just the sections out of the book. So we'll be covering the history of soils in Ireland, soil formation, basic soil classification and properties of soil. So again, you all have access to your book, whether it's hard copy or PDF. The book is available to you, and it's just for extra reading material really. The notes that I have done here are basically the book just condensed into the most relevant and important points for you. So I suppose just to look at it before we dive in, soil. So we need soil for our grass to grow. So I suppose it's important to get the soil right before we look at growing our grass. So I suppose the maintenance and improvement of soil fertility, it is both grass growth on the farm. We have to get the soil right first of all. So the pH status of a soil plays obviously a huge important role, as nutrients may only become available to the grass plant then at certain pH levels. So I'll cover it further on the slides, but we want our pH to be at 6.5 for grass to grow in our soils. So just looking at the history, I suppose, of soils first of all, and this is based in Ireland. So Irish soils range from approximately 6,000 to 7,000 years old in the north and greater than 15,000 years in the south of the country. So basically that's how long ago these soils have been formed. How do we define as the surface layer of the Earth's crust that is capable of supporting life? So that's exactly what it is. It supports life. Without it, we wouldn't be here. So we need the Earth in order to support life. Soil type depends then on a couple of things. So the geology, the topography, climate, vegetation, and influence of nature, and that also includes humans. So that's depending on the type of soil that you have, those factors based on that. Soils then obviously will vary on each farm. So you have your heavy soils, your light soils. So it depends on the location you are, depending on what soil you have. So I will show you how to, I know some of you might want to find out what type of soil you have on the farm. Some of you might be soil sampling already and know what kind of soil you have, but I will show you the Teagasc soil map where you can go and figure out the soil in your area. So I suppose, how is soil formed? So many different factors interact for soil to form. So mainly your parent material, so the likes of your rocks. So we'll go through the different types of rocks in a minute. Weathering, so rocks are broken down then into smaller pieces, and this is known as weathering. Your landscape, so your topography, your climate, so your temperature changes, your erosion, rock particles and soil are moved by wind and water. So depending on the climate, whether it's really hot, really cold, you have the likes of your freeze-thaw action. We'll go through that as a type of weathering. Influence of living things, so trees, your fungi, bacteria, viruses, and a part of our time. So obviously over time, we mentioned that how long soils have been there. So over 15,000 years in the south of the country and 6,000 to 7,000 years old in the north. So like over time, soil does change. And of course, influence of ourselves. So influence of man, ourselves, farmers, animals, what's going to change in the soil, what's going into the soil. So look then at soil formation, different rock types. So anyone who would have done Leaving Cert Geography or even Junior Cert Geography would have done the rock types. So very basic, we have 3 different types of rock: igneous, sedimentary, and metamorphic. So a lovely short answer question there. Name 1 type of rock, or name 2 types of rock. Very nice question, and it's igneous, sedimentary, or metamorphic rocks. So just to go, we have 2 types of igneous rocks then. So they're formed from hot molten lava. Minerals are found within these rocks in the form of crystals and are the primary source of minerals in our soils. Examples, so one very common example, anyone who has been to the Giant's Causeway, so you can see the picture here, that is your basalt rock, which is a type of igneous rocks. So very common, if you picture the Giant's Causeway in your head, that is your basalt rock. Granite then can be found on the Wicklow Mountains. So this is just a picture here of granite on the Wicklow Mountains. And it's your white kind of a rock, so your granite rock. Igneous rocks are hard and they're slow to weather. So anyone who has been to the Giant's Causeway, that is the exact image that you'll see whenever you go up there. So they are slow to weather. So they're breaking down obviously over time, but very, very slowly. And the same with our granite rocks. Our sedimentary rock then, so another type, they're formed from weathered material. So your rock, your clay, your silt, and your sand. They're further compressed by more material, resulting in rock formation. And examples of our sedimentary rock are shale, sandstone, and limestone. So shale there, we can see the picture. It's compressed clay, basically. Sandstone and limestone then, so anyone, shale, anyone who lives beside the sea, you will be able to see shale. So it's kind of like on your cliff edges. If you ever notice wherever the cliffs of Moher, you'd see this type of rock evident beside the cliffs. Sandstone and limestone then, another two types of rock. Sticking with County Clare, sandstone can be seen beside the sea in West Clare, and the famous burn. So limestone can be found in the burn. So this is our picture here of the burn, and there's your limestone type rock up there. Metamorphic rock, so our third type of rock, it's formed from igneous or sedimentary rocks, which have changed due to extreme pressure temperatures. And examples include slate, shale, slate, so that's from your shale, your quartz is from your sandstone, and marble from your limestone. So there are three different types of metamorphic rock. Again, lovely short question. List two types of igneous rocks, list two types of sedimentary rocks, or list two types of metamorphic rocks. And that's where you would just give examples of whatever your sandstone, your limestone, whatever criteria or wherever group it falls under. Our soil formation then, so weathering. So we have three different types of weathering. Again, anyone who has done geography would have covered this previously. So your physical weathering, that's where parent materials are broken down into finer particles, and that's by changes in temperature, frost, wetting and drying, and erosion by water and wind. So your physical weathering, we'll just jump down to the picture here, is known, it's like your freeze thaw action. So in the picture, we can see in picture 1, the water is collected in the crack inside in the rock. Picture 2, then the water freezes and it actually expands the rock, forcing it to the crack to widen, open wider. Picture 3, then the ice thaws, it contracts, and water gets deeper into the cracks again. And eventually the rock is going to crack and break into two pieces. And that's what your physical weathering is made up of. Chemical weathering then, so your parent material is broken down by chemical reaction. Carbon dioxide in the air dissolves rainwater to form carbonic acid. So like what we call our acid rain. And when this acid comes in contact with the rock, it wears them away. So basically it's wearing away the surface of the rock over time. So obviously time plays a huge factor, that it would take years and years and years for the rock to actually break down. Your biological weathering then, so this is caused by organisms which fragmented material by both chemical and physical means. So your plant carbon dioxide and water equals your carbonic acid, and then the plant roots penetrate cracks in the rock, which increase pressure, causing further to open. So like your freeze thaw action, it's breaking the rock into two. Soil formation then, so the image here is basically your soil profile with your different soil horizons. They can be seen as you dig down into soil. Some can be more evident than others. So you can see from the diagram here, we have our horizons O, A, B, and C. And you can see the distinctive differences of them. So the color goes lighter as you move down along. And at the very bottom is your rock. So if you ever dig into a soil and you hit rock, you're at the bottom. So that's where your bedrock is, at the very bottom. The classification of soils then, so there's 11 major classes of soils in Ireland. So they're classed based on their physical and chemical properties. Soil colour, texture, structure, and other properties are all considered when naming a soil as well. And just going to take you, so the link here at the bottom is basically the soil map that you can go to see what kind of soil is in your area, if you want to have a look, but I will show you how to. So I follow the link and it's bringing me to the Environmental Protection Agency. So this is the website here. So I'm just going to go to maps. And basically, look, this is the map of Ireland, and as I zoom in, I can see the different colors, and that's basically the different tiles. So I'm going to go to the burn, seeing as we were talking about the burn previously, and just take a look at the soil there. So just keep zooming in. So I'm up here around Curfin. I'm just going to click on the soil, and brings up the table here, so the different types of soil. So we can see it's a fine loamy drift with limestone. So I'm just going to click in here, and look, it's telling me the soil, the description, the texture. So it's a fine loamy soil, and it's saying that there is limestone in it. So we have said previously that, yeah, there is limestone in the burn. So you can check that for any place in Ireland. It's just on the Environmental Protection Agency, where you go to the soil map. So that link is there in the PowerPoint. Okay, so as I said, there are 11 major classes of Irish soils. They're all your classes down long. So you have your peats, your blanket peats, your podzols, brown earths, your water glaze, basin peats. So they're all your major classes of Irish soils, and they then have subclasses underneath them as well. Properties of soil. So farmers must understand the following properties in order to manage their soil. So the soil particles and pores. So this is basically the space between the solid matter in soil. So some soils would have larger pores, some would have smaller. So water and air are held in the soil pores, and water holding ability depends on pore space and size. So the ability to hold water inside in the soil would depend on the soil particles and pores. The water capacity, so the amount of water which can be held in the soil, is called retention capacity. And the amount of rainfall, evaporation, plant transpiration, and drainage all affect this. So obviously, some parts of the country might be affected more than others, where there's heavier rainfall. So that would affect the water retention capacity of the soils. Aeration then, this is just the pore space is filled with air, and your nutrient holding capacity. So this depends on parent rock, the colour, depth, texture, plant type, and the climate, of course, as well. So the organic matter. So this is a massive thing in soil. So organic matter is made up of dead remains of plants, crops, and animals, which undergo a biochemical process to decompose into humus. And its functions, so the functions of organic matter, it's also known as OM, so organic matter. It improves the soil structure, it reduces soil compaction and increases water infiltration, it retains nutrients, it's a food source for microorganisms, and it darkens soils which aids heat retention and warms soils earlier in spring. So I suppose the darker, you ever heard of someone, we've said darker clothes attract the heat. So when you're wearing black during summer, you feel a lot warmer. And that's because the darker clothes attract the heat. It's the same for the soil. So the darker colour attracts the heat, and in turn will heat up the soil quicker. And then obviously grass will grow quicker then, especially in springtime. So it takes time for the soils to heat up in springtime. And obviously the organic matter inside in the soil will help the temperature rise quicker. So moving on then to learning outcome 2. So in this learning outcome, we'll describe the physical and chemical composition and features of soils and their relevance for modern farming practices. So what's covered in this section? The composition of soil, soil texture, soil structure, soil weather interactions. So just looking at what soil is made up of. So there's a lovely pie chart here. Again, a nice question where you could be asked maybe to label the pie chart. And I suppose, what is soil made up of? So it's made up of 45% mineral matter, 25% water, 25% air, and the other 5% is made up of our organic material. So to picture that pie chart, so 45% mineral matter, 25 air, 25 water, and 5% organic material. So soil texture. So that's basically how soil feels. So it's made up of the fineness, the coarseness or fineness of soil particles, and the size of soil particles. So texture affects drainage, water retention, and usefulness of the soil. Your soil pores, again, the spaces between particles. This affects your water retention and availability to plants. Pores can be divided into three sizes. So you have your large, medium, and your small. And I suppose this affects the water retention of the soil as well. So a good textured soil will contain all types of pores as well as organic matter. So it'll have large, medium, and small, and have your organic matter as well. So your different types of soil, so your clay soil, sandy soil, silty, loams, and organic soils. So we have the advantages and disadvantages here in this table. So basically the texture class is based on the proportion of sand, silt, and clay in soil. So take a look at the advantages and disadvantages. Another typical question could be to list one advantage of a clay soil. And the advantage here is hold water well and tend to be rich in nutrients. And you could be asked for a disadvantage of silty soil or a disadvantage of loam soil. And look, your disadvantage there usually needs draining for your loam soil. So your soil texture, then looking at your soil pH. So I mentioned earlier that the optimum pH for plant growth is 6.5. So you've all probably seen the pH scale. So it goes from 0 to 14, with 0 to 7 being acidic, and your 7 is neutral. So 0 to 6 is acidic, 7 is neutral, and then 8 to 14 is your alkaline soils. So we want our soil to be 6.5, and that's for optimum grass growth or plant growth, whatever is in the soil. So the same for barley, your optimum pH is 6.5. Structure of soil. So soil structure is the way in which soil particles and pores are arranged to provide a good tilt or crumbliness. So in one of the practicals, you'll do the soil structure, soil texture. So I suppose when you roll the soil together in your hands, you'll see how coarse or how fine the soil is. Good structure prevents capping and erosion. It also helps ensure sufficient rooting depth for plant growth. I suppose improving soil structure, how could farmers do that? So good cultivation, so avoid travelling on wet soils to prevent compaction, whether that's with your machinery or with your animals, so that you're not poaching the land. Varied cultivation techniques, avoid plough pans, and we'll go through what a plough pan is in a minute. Maintain your organic matter in the soil, and regular liming. So we'll go through liming shortly, the advantages and disadvantages of it, and I suppose the optimal timing of applying lime. So your soil and water interactions. So weathering is the breakdown of soil, rocks, and minerals. Your freezing and thawing, which we mentioned, water flowing, wind and rain are major causes. So we mentioned about our weathering, our erosion. So erosion is caused by the same processes, however the soil is carried away. So erosion is happening in everyday life, but it's just happening very slowly. So soils are eroding, rocks are eroding to form soils, but it's a very slow process. There's just a short clip there on soil formation, so on weathering. You can follow that link on YouTube. So moving on to learning outcome 3 then. So describe agriculture practices affecting soil structure, their implications for soils, and key soil improvement practices. So how can we improve our practices for our soil? So I suppose what we're looking at here is we're looking at drainage, our rotation, the effects of agricultural practices on soil, and I suppose how to avoid compaction as well. So anyone who knows what this is here, so this plant is rushes. I'm sure everyone probably has seen rushes before. Not a good thing to see in your soil. They're actually a sign of a poor drained field where water logs in the field. So often people would say, oh, you have rushes at home. You don't want to admit that you do have rushes because they're obviously a sign of poor drained fields. So drains are installed to control the water table or basically to remove excess water. Indicators of poor field drainage, so our rushes, which are here, surface water for on the or surface water, yeah, for long periods of time, patchy growth, so you can see where water is logging and obviously the grass is not able to grow, a grey white rusting colour on the topsoil, and shallow root system. So look, all of these in turn lead to poor drainage, and I suppose you should be looking at draining the soil in that sense. So drainage then, climate and soil type are the two main factors that influence drainage. So obviously whether the ground is really wet or really dry. So climate determines water input into the soil, and soil type determines how quickly the water moves through the soil. There's three different types of water. So your hygroscopic, your capillary, and your gravitational. So again, another question to define one of these types of waters. So your hygroscopic, it's microscopic water, so it's not available to the plant roots. So you can see here your hygroscopic water. So it's the remaining water strongly adheres to soil particles. So it's caught onto the soil particles. It's the water that's left in the soil after other water is drained away. So your capillary then is available to plants but cannot be removed by drainage. And your gravitational water is basically your excess water, and this can be moved or can be taken away by draining your soils. So drainage then, so picture here, poached fields, so you can see obviously animals were left out, whether it was in a wet summer, the back end of the year, they were left out just to get, leave them out for another couple of days. Obviously land was wet, poaching happened, and it rained down then on top of the poaching. And that's where we can see the water inside in the holes. So your harmful effects of water in the root zone, so the topsoil, so reduced growth and yields. So the water basically excludes the air, and we need air for it to grow. So it excludes the air and you'll see patches of growth then happening. Due to excess water, soils are slower to warm up in the spring, poorer soil structure, easier poached, and then liable for compaction. They're prone to harbouring plants, so like your mildew, which is in wet surfaces, and animal diseases, so such as fluke. Another thing that can be seen in wet soils is leather jacket. So I'll come to that in a second, but not everyone knows what leather jacket is. So basically it's the larvae of the crane fly, but it can be found in wet land. So just go and show you a picture there. So this is your leather jacket. It's the larvae of the crane fly. And I suppose the significance the leather jacket has on land is that it can actually reduce growth. So you can see grass is going back in patches. Obviously, this can reduce, it'll reduce grass growth, and you may not have enough grass then to let cows out into fields. So this happens a lot of the time beside the sea. Leather jacket will be seen mostly over inland counties, but beside the sea, and I suppose it can have a major effect on farming when cows or when grass growth is not there because of the leather jacket. So basically it's eating up the grass, and it's not growing back in these patches. So could look out for the leather jacket. It's hard to see, but I suppose the indicator is your patchy grass that your leather jacket is on the land. So I suppose looking at drainage then and getting rid of our water. So aside from excess rainfall and poor soil structure, poor drainage can be caused by our springs, high water table, or impervious soils. So look, obviously farmers do tend to drain their soil when it's wet, and we'll look at the different types of drainage systems. So a main drainage system receives water from a field drainage system and transports it to an outfall. Field drainage system then removes water from waterlogged soils. So there's two types of field drainage systems. First type is groundwater drainage, and the second is your shallow drainage system. So your groundwater drainage, it's a network of field drains collecting groundwater, which can move through soil layers. It lowers the water table and reduces water storage in the soil, so the land is not becoming waterlogged. It's installed at a depth of 1.5 to 2.5 meters, so that's your drain going down the way. Install drains across a slope to intercept as much groundwater as possible. And I have a diagram in a minute, I suppose, showing you the different types of drainage systems. Your shallow drainage system then, so used when soil permeability is low at all depths. Measures are implemented to promote infiltration. And I suppose mold drains, gravel mold drains, subsoiling, ripping, deep ploughing, and slit aerators are all types of shallow drainage systems. Just a note there, and you can see more on this on pages 31 to 32 of the book. So this is your different types of, your gravel that can be used in your drains. So gravel, broken stone placed in a drain or trenches over pipes, and that's just to cover up your pipes. It acts as a filter, so provides a connection between the pipe and permeable soil layers and subsoil layer or mold drain. And it improves the water flow into the pipe as well. So it moves down through the soil and down through this gravel or your broken stone and into the drain. Your soil pan then, so hard layers of soil impermeable to water and plant roots don't allow them to pass through. So this may cause soil to become waterlogged. So basically a hard pan on the top of the soil. And I suppose if you just think about it, if you put plastic down on top of something, the water is not going to go down through it. So I suppose it's a hard pan on the top of the soil. And if we had that plastic along the top of the soil, it'll become waterlogged. So the water won't be able to go down through the soil. It's most prone in compacted layers of intensive tillage land, and subsoilers or rippers are used to break up the hard layer. So basically just break it up so that the water can go down through the soil. Your subsoiling then a means of bursting the soil to create series of cracks and to loosen compacted areas. So it's just basically, again, to break up your soil so that water can go down through it. Ripping, again, another shallow drain system, severe form of subsoiling using heavy rippers drawn by a bulldozer. And again, this is just to break down the soil so that the water can go down through it. Your deep ploughing then, so involves ploughing to a depth of 0.3 to 1 meters. That's quite far down in the soil. It has two functions, so it mixes up the subsoil and peat while also breaking the pan. So it'll mix up your, anyone has ever seen ploughing, it turns the soil, it mixes up the soil, and it is also breaking the pan as well. Your silt aerators, so used on grassland, targets the top 10 centimeters of soil. So like that versus our deep ploughing, where it's going down 1 meter, versus our aerators are only going down the top 10 centimeters of soil. So it's only the top layer that's been turned here. So it increases infiltration rates, it introduces air to grass roots and soil, which in turn leads to increased grass growth. It reduces slurry and fertilizer runoff so that it's going down into the soil. It improves microbial activity. It helps the breakdown of nutrient and crop debris. And you can see that there's two different types of aerators here. So one like the type of like your roller, and it's just small incisions into the ground to let water, slurry, nutrients down into the soil. Designing your drainage system then, so you'd have to consider the following: the layout, so what layout you're going with, whether it's a type herringbone type pattern or a grid type pattern, depending on the slope, the depth you're going down, the spacing, so how wide the drains are going to be, how many drains within the field, so the spacing, the depth of water table if needed, and I suppose the types of pipe and the sizing of the pipe, depending on what's needed. Okay, so your drains, so your grid iron, your regular lateral drains into a main drain, so like this here. So going down along the field, your small drains into your main drain, or your herringbone. So think of your herringbone parlour. So it's just the layout of it. So you have your main drain down the middle of the field, and you have your smaller drains coming down with your water into the main drain. Your random then and interceptors. So random here, random points. So it's at where the wet areas of the field is. And then your other type used to intercept springs or surface and groundwater moving down a slope. So the depth, so the soil type greatly affects drain depth. So again, you know how to check what your type of soil you have on the farm. Light soils require deep drains, heavy soils need shallow drains. The spacing, so the deeper the drains, the wider the spacing. Spacing ranges from 15 to 25 metres in heavy soils and 20 to 40 metres on your permeable soil. Your type and size then of your drain. So open ditches carry large volumes of water and are easy to maintain. So your pipe drains is another option. So you can put your pipe in the drain, depending, obviously you have to depend on the diameter must be considered, how large the pipe needs to be to carry out the water. So your obvious benefits of your drainage system. So obviously it's getting the water off the soil. So the water is able to move down. It's not on the surface of the soil. And then in turn, then it's obviously going to increase your grass growth. You'll have a longer growing season because the grass is growing. There's no water. The temperature is correct. Better ground access, so less poaching. The land is not wet. Cows or animals or tractors can travel the land at the back end of the season, so better ground access. Reduced imported feeds, concentrates, so we've more grass growth, so less need for concentrates, and it allows for higher stocking rates on the soil. So the soil can hold the animals. So looking at rotation, then matching crops to farms. So when selecting crops, there are a number of factors to consider. So I suppose this is mainly in your tillage point of view, really. So the soil texture, suitability of each soil type, your mineral considerations. So some soils are mineral deficient or contain excess minerals. Climate, so your wind, your shelter, rain, frost, sunshine, and the aspect are all very important. And your physical considerations. So some farms have physical barriers to cropping. So maybe the slope, stoniness, the nearness to urban areas, and flooding could all be contributing factors to your physical considerations. We spoke about the hard pan and surface capping. So implications of agricultural practices. So your surface capping is basically a layer on the top of the soil. So it occurs in fine, sandy and silty soils mainly. And when rain falls on bare soil, it damages the surface structure and creates a surface cap. And it's harder for seedlings to emerge. So again, think of your plastic layer. Just for example, if we had a layer of plastic on the soil and seeds wouldn't be able to shoot up through the hard pan. So we're looking at it reduces water infiltration and it leads to erosion then as well. How to reduce it then? So produce a fine seedbed, increase soil organic matter content, retain residues from previous crops, and harrow ground to break the die cap. So I suppose again to break up the cap of the soil. Reducing negative impacts of soil inputs. So I suppose regular soil analysis. So to be testing the soil to check for the pH and the nutrient levels. So I suppose that you're not spreading fertilizer just for the sake of spreading it, so that you know what you need to spread. You'll know that by testing the soil. Work out how much NP and K are supplied by manure. Monitor field for weeds, pests and diseases. Apply inputs as the correct time to avoid runoff into watercourses. So I suppose not applying slurry in the closed periods because the tanks are full. So that's a big no-no. You're not gaining from it. The temperatures are not right in the soil. So there is a reason for closed periods. Like the soil is not going to use those nutrients if you're applying it in December. So it's illegal to apply fertilizer in the closed periods. And I suppose that's one of the main reasons and we don't want it running off the soil and into water courses, which can turn into nutrient enrichment and, you know, algae on the water. And, you know, it has negative effects on water courses. So avoid spreading near your hedgerows or your water courses, again, for those reasons, and checking machinery calibration. So I suppose that you know how much fertilizer is going out, that it is calibrated correctly, that you know how much is going out to the acre, and you know that it's calibrated correctly from day one. Harvesting, so removing crops during harvesting removes nutrients along with damaging soil structure. Ways of reducing impact, so use minimal tillage, growing a cover crop, adding manure to replace lost organic matter and nutrients, and use a crop rotation. So follow a low residue crop with one that leaves residues. So a win-win situation. So one crop might take a nutrient out of the soil, but another crop that you're sowing the next year might actually add that nutrient back into the soil again. So, for example, your peas after wheat for that reason. Your soil compaction, so soil particles are squeezed tightly together and pore space is reduced. Compaction reduces drainage, aeration, and root growth. It often results in runoff and erosion. So how to reduce your compaction, we've said already, minimal tillage, cultivating when soil is not too wet, avoid the use of heavy machinery on wet soil. So look, heavy animals or machinery, they will cause compaction on the soil. So again, wider tires to increase surface area. So if you use wider tires, there's less compaction on one area. It's spread out over the tires. Addition of organic matter, and avoid animals poaching the ground. So again, at the back end of the year, when you just want to keep the animals out as long as possible, you want to get the grass growing for the spring. So I suppose you don't want compaction and the animals to poach the land in October, November, December. So like you should be starting housing, you know, the 10th of October onwards. And obviously it varies in different parts of the country. Some farmers could have animals out longer than others, but I suppose to prevent poaching, keep that in mind that you don't want the land to be poached. And the last learning outcome, so learning outcome 4, discuss soil nutrition and related environmental legislation, sources and roles of nutrients, maximising nutrient value of fertilisers and farm byproducts, and storage and practical implications at farm level. And I suppose what we're looking at in this section, soil nutrition, nutrient deficiencies and biochemical functions of nutrients, maximising nutrient value of fertilisers, including the role of pH, environmental legislation, and storage and practical implications at farm level as well. Okay, so looking at soil nutrition, so our major nutrients N, P, and K. So our nitrogen, phosphorus, and potassium are the main nutrients supplied to the soil through the yard, farmyard manure, and artificial fertilizer. These are commonly called our primary fertilizer elements. Your calcium, magnesium, and sulfur then are secondary elements. So you can have a look here, your nutrient, so your NPK, the source, so where it's got, and what it does. And same for your sulfur, calcium, and magnesium. Your minor nutrients then, so these are your trace elements. They're needed in much smaller amounts by plants, but they are just as important as our macronutrients. So examples of our micronutrients are magnesium, copper, molybdenum, boron, iron, cobalt, zinc, and silicon. So I suppose a question there could be to give an example of a macronutrient, and that's your N, your P, your K, so your nitrogen, or give an example of a micronutrient or minor nutrient, and that would be the likes of your copper. How plants use the nutrients. So plants take up nutrients through their roots. So we need to ensure that the fertilizer or the nutrients are going down into the soil so that the plant can uptake it in the roots. And I suppose that it's not being run off the soil. And I suppose obviously that's to make sure that we're spreading in correct conditions so that the soil or the nutrients aren't running off into water courses or into drains. So nutrient uptake is influenced by nutrient type, nutrient concentration, soil temperature, and the amount of moisture. So your soil nutrition, here we have, again, your nutrient deficiencies cause poor performance in plants. Nutrients which move within the plant are called mobile nutrients. Calcium and boron are immobile nutrients. And the table here, I suppose, gives you an overview of the deficiency symptoms of the major nutrients. So I suppose one common thing in all the deficiencies would be growth deterioration. So that would be a common deficiency symptom of any of our major nutrients. And again, here, your minor nutrients are in the table here. So yellowing of leaves is a massive deficiency in a lot of minor nutrients. Deficiencies and functions of nutrients, so are phosphate and potash. So they're required in lower quantities than nitrogen as they are returned to soil through the animal dung and urine. And the requirements are higher for silage ground than grazing ground. Plants can take up excess amount of K, which reduces uptake of magnesium, resulting in crop deficiency or grass tetany in cattle. So I suppose magnesium is required for the prevention of grass tetany, but I suppose plants can take up the K, so our potassium. So our potassium is needed for the uptake of magnesium. So to just bear that in mind, that K works with our Mg, magnesium. Nitrogen, one of the most important nutrients, it aids the development of leaves and stems, so nitrogen is needed for growth. Plants lacking in N are yellow in colour, dark green foliage is an indication of adequate N levels. And good growth, obviously, as well. So nitrogen is a gas which is not usable by plants. It must be converted into a usable form. So I suppose this is where you look at your nitrogen cycle. So this basically outlines what happens in the nitrogen cycle. And I suppose bacteria is fixed and it's turned into, our nitrogen is turned into forms that can be used by our plants. So lime then, lime is a fertilizer and soil conditioner. So all liming materials contain calcium. They're essential for good grass and crops. It maintains plant health and fertilizer efficiency. A ton of lime per hectare will raise the pH by 0.2 to 0.4 units. So I suppose if you've low pH soil, if you apply lime to the soil, it'll increase the pH. Soil tests will recommend lime application amounts. So if you're testing your soil, it will come back in the soil report the amount of lime to apply to the land. Lime should be sprayed little and often, so don't exceed 7.5 tons per hectare. Generally, farmers should apply or should lime 20% of the farm per year. And one important point there is to never spread lime on grassland to be cut for silage in the same year. I suppose you should leave sufficient time, up to about 3 months, especially in dry weather. And I suppose the reason behind this, why we leave this time between applying lime and closing for grass silage, so the lime to be fully washed into the soil. If lime is picked up when cutting silage, it may affect the good preservation conditions for the silage. So it's very important that we leave the time elapse before, so that we spread the lime in time, so that we're not cutting the silage too soon after liming the soil. And I suppose key indicator of when to apply lime. So once fields have been grazed off and grass covers are low, it is an ideal time to apply lime to fields. Advantages and disadvantages then of liming. So mentioned already, improves plant root development, it improves soil structure, stimulates the availability of soil NP and K and other nutrients. It increases earthworm activity, improves clover growth, and it improves the uptake of most trace nutrients. And one thing that's not mentioned here, increase the pH of soil as well. So we mentioned that in the previous slide. Disadvantages of liming. So increases the availability of the trace element molybdenum, which in turn reduces uptake of copper for animals. It reduces the availability of several essential trace elements, especially manganese, boron, and iron. But I suppose there are so many advantages, they weigh out the disadvantages, and there is ways around getting over these disadvantages. Spreading ground lime. So I suppose there's two main types of ground limestone. They're available nationally, so you have your calcium and your magnesium. Calcium lime generally is available worldwide, or sorry, widely across the country. And I suppose magnesium then lime is mainly available in the southeast of the country. But I suppose it can be got, can be ordered in all parts of the country. You're maximizing nutrient value of fertilizer, so including your pH. So this table just shows you the organic manure, so what the nutrients are inside in the organic manure. So we have our cattle slurry, pig slurry, poultry, and our farmyard manure. So our FYM is made up of straw, the cleaning of animals after calving. It's all the dung in the farmyard manure. So I suppose dry matter of cattle slurry is at 6.3%. One of the modules you will be testing the DM of slurry. The NP and K, so this is in kgs per ton, these figures here of each type of slurry. Timing of application has a strong influence on N fertilizer value. So your N availability is highest in springtime. And the best possible use of N is your cattle slurry. So 6.3 dry matter percentage, 2.4 N kgs per ton, 0.5 phosphorus, and 3.5 of potassium. So at a rate of 33,000 litres per hectare during February, March. So I suppose you see a lot of farmers going out with slurry February, March time, and again then after silage or grass has been cut for silage on the fields. Your low emission slurry spreading has come in massively in the last few years. So I suppose your trail and shoe, your dribble bar, and the low emission slurry spreading are less techniques, minimize N losses, and ground can be grazed sooner. So I suppose it's getting the slurry and the nutrients into the ground quicker so that it minimizes N losses into the atmosphere. So like the splash plate, it's not been thrown up into the air, it's going directly into the ground, and in turn then our ground can be grazed sooner. Applying organic manure to silage ground mid-season. So apply when weather is showery, apply when slurry consistency is thin, within 3 days of cutting silage. And I suppose applying organic manure to grazing ground in mid-season. So your store slurry for a minimum of 30 days. Aim to use diluted slurry. So when your slurry is agitated, a lot of farmers, it's so thick, the dairy washings, if you have a tank that's solely just so like a slatted tank in a slatted shed, wouldn't have dairy washings in it. So generally farmers would take the dairy washings, add water basically into your full slurry, so to mix it up and to dilute it, to less thicken it. Allow a minimum of 30 days between spreading and grazing. Do not frequently apply cattle slurry to the same ground grazed by cattle, as this helps to avoid buildup of K, so our potassium in soil, which increases grass technique. So we said that earlier about our magnesium and our potassium. So our artificial fertilizers. So you have your N fertilizers, so your CAN, your urea, fast-acting phosphorus fertilizers, your Super P, your triple super, and slow acting then will be your rock, your phosphate type fertilizers. So it is widely used in compound fertilizers. So for example, 10-10-20, 18-6-12 will be very common type fertilizers. potassium, so your muriate of potash, so 60% potassium oxide, and your sulfate of potash is 48% potassium oxide. Your nitrogen, so your CAN, 27% nitrogen, your sulfate of ammonia, 21% nitrogen, and your urea is 46% nitrogen. They're very common types of N used on grass. Looking then at environmental legislation. So the most up-to-date info on environmental schemes is available on the Department of Agriculture website. So our GLOS, which is Green Low Carbon Agri-Environmental Scheme, is the agri-environment scheme under the Rural Development Programme. Annual payments up to 5,000 can be made out in GLOS. So a lot of farmers, a lot of you might be in GLOS. 7,000 possible with priority environmental assets. Farmers undertaking priority actions get priority access. So I suppose all options aim to protect and enhance various environmental aspects. So for example, your grassland or your wild birds. So a lot of people in GLOS have to, the likes of your back boxes, your wild bird cover, have to implement things to protect the environment. So our storage and practical implications then. So we all know that there are certain periods of time that we can't spread slurry. Farmers have to have a certain storage period depending on the county they're from. So I suppose the nitrates regulations deal with three main areas. And I suppose they are keeping soil water to a minimum, collecting effluent organic fertilizers, and storing effluent and our organic fertilizers. So I suppose storage is required for the following. So our livestock manure, we have to have adequate facilities to store our livestock manure. Same with our dairy washings for the dairy farmers, all effluents. So any effluent there needs to be a storage tank for it. And all storage facilities must comply with the Department of Agriculture specifications. And look, this is a dungstead here. It's an approved dungstead from the Department of Agriculture for holding the likes of your FYM. Looking then at the storage facilities. So I suppose each county under the nitrates regulation, they divide the country into 3 zones. And I suppose this table here looks at the different zones. So you have Zone A, Zone B, and Zone C. So the counties in Zone A, Carlow, Cork, Dublin, Kildare, Kilkenny, Laois, Offaly, Tipperary, Waterford, Wexford, and Wicklow. So they're all the counties with good grass growth we'd know them as. So I suppose those counties don't need as much storage as other counties. So they need 16 weeks storage. And I suppose generally they would be able to get cows out earlier and have cows out for a longer period. So therefore don't need the storage in those counties. Zone B then, so Clare, Galway, Kerry, Limerick, Longford, Louth, Mayo, Meath, Roscommon, Sligo and Westmeath all need 18 weeks slurry storage. Zone C then is broken up into 2 parts. So Donegal and Leitrim, they need slurry storage for 20 weeks, and Monaghan and Cavan are 22 weeks slurry storage. So I suppose another typical question on this could be how many weeks slurry storage does a farmer in Clare require? And your answer there will be 18 weeks. Or in Zone A, how many weeks slurry storage is required? And 16 weeks is your answer for that. So look, that is your tutorial on chapters 1 to 4. Exam is based on these presentations. On chapters 1 to 4, there is questions from each learning outcome. As I said, there's 15 short questions and 2 structured questions on the exam. So if you have any questions, you can email me at online@paliskenry.com and I'll be able to answer your queries there.